Hi there, I'm Hao, and this is just another video of me solving random difficult problems. So let's begin. So given the head of a linked list, we move the ends node from the end of the list and return the head, right? So let's say we have 1, 2, 3, 4, and then 5. We can use two pointer to solve this problem. So how do we get access to the ends node from the end of the list? So let's think about it in a different way. Instead of thinking about it like from the end of the list, let's think about it like in the front of the list. So if the slow and the fast pointer is have distant end, right? So let's say we want to return the second n is equal to, we want to return the second node from the end, which is this one right here, right? So 1 and 2, distant of 2, right? Instead of thinking about it from the end, we can think about it in front. So if we create the distance of n between two pointer, so let's say the fast pointer is n step uh ahead of the slow pointer, right? So by the time the fast pointer reach the end of the linked list, then the slow pointer will be exactly at the nth node from the end, right? So we can try that. So so right now the slow and the fast pointer is have distance of 2. So the fast pointer is two step ahead of the slow pointer, right? So we can keep moving the slow pointer and the fast pointer here fast, right? One step at a time, right? Fast and then slow and then fast. So when the fast pointer is null, right, which means that the slow pointer will be exactly at the nth node from the end of the linked list because we create that distance before we iterate. So we want to remove this node, right? And we don't have access to the previous node because it is a singly linked list. So we need to stop one node before that, which is here, right? So we can redirect the next pointer to this, right? So our condition can change to be when the fast dot next is not null, right? So if the fast dot next is null, then we know that we are uh, at the previous node before our target, right? So at this point, we can reset our next pointer to so slow dot next equal to slow dot next, right? So this node right here will be garbage collected later on. So let's look at a different example. So we have 1 and 2, 1 and 2. So n is 1, right? So it is slow, it is fast, right? So fast is one step ahead of slow. And then the condition I said earlier is why fast dot next is not null, right? But now fast dot next is null. So we just have to go ahead and reset it, reset the next pointer, right? So slow dot next equal to slow dot next, right? Like this. And then this node will be removed from the link list, right? And will be garbage collected later on. Let's look at an edge case here. So what if we only have one node, right? So the idea is that we want to stop one step before the target node, right? So that we can reset the next pointer. But what if we only have one element in our link list? So n is 1, right? So slow is here, and the fast is here. Fast, right? So this is null. In this case, what can we do? So when when we set the so when we create the distance for the between the fast and the slow pointer at the beginning, right? We're gonna iterate the fast pointer and step ahead of the slow pointer. Um, After that, we can check that if the fast pointer is no, then we can just go ahead and return slow dot next, right? Which is no here, right? So how do we know if the node we want to remove is the first node in the linked list? So if the node we want to remove is the first node in a linked list, then we want to return slow the next pointer that we want to return th this one, right? The next node of the first node, right? Um, yeah, so this will be our new head. Right? We can just like return this one. Um, so let's say when we create our fast and our slow pointer here, fast and slow, right? Let's say we have five node and n is equal to five, right? If n is equal to five, which means we want to return the fifth node from the n. So 1, 2, 3, 4, 5, which is the first node over here, right? So when we create a distance between the fast and the slow pointer, 1, 2, 3, 4, and then 5, right? So after we assign the distance for them, if the fast pointer is no, then we know that the node we want to remove is the head of the linked list. So in that case, we can just return the slow dot next or the head dot next here, which is this node will be our new head, right? Same case for this one. All right, so let's go ahead and code this up. So we can have uh, a fast and a slow pointer starting at the same place, right? And before we even start traversing, we want to set the distance between the fast and the slow pointer, right? So we can iterate to n. So we just do fast equal to fast and next. And we know that we will never be outbound because of the constraints right here, right? And will be less than or equal to the size, right? So we don't have to worry about the fast gain no. Yeah. Okay, and so we can check, right? If we don't, if a fast pointer is no, after we set the distance, then we can just return load up next, right? Or just simply like head that node. Okay, same thing, right? Which means that the first node we want, the node we want to return would be the first node, the head of the linked list. And then we can iterate through the linked list now, right? So when the fast.next is null, which means we are a node right before our target, right? We can increment our fast and our slow pointer right here at the same space, right? So when we break the while loop, then we know that the slow pointer, when we break our while loop, um, we know that we will be one step be before our target, right? Right. That is super clear. So if you want to delete four, then we will be the slow pointer will stop here, right? When the fast.next is empty, is null. Right? If fast.next is null, then n equal to 2 here, right? The distance is 2, right? And if the fast.next is null, we break our while loop, and at that point, we know that the slow pointer will be pointing up here, right? 3, which is one node away from our target. So now we can just reset the next pointer of the slow. So we can do slow equals slow that next equal to slow that next, right? So we can return the head. submit, and it passed. Thank you for watching.